Exercise 12a, Inverse Matrices. This entire chapter, that being chapter 12, is essentially a series of exercises devoted to applying our understanding of how matrices can be added, subtracted, and multiplied to a variety of different scenarios, with the ultimate objective to be able to apply them to our understanding of recursion and recursive equations and relations. But we need to start with the initial nugget of an idea, which is the concept of an inverse. Now, the main reason we do inverses is that in the whole matrix language so far, we have no such concept as divide. You cannot divide a matrix by another matrix. Doesn't work that way. But there are some operations that we really need to be able to do that act as if it's a division. How do we go about doing it? Well, let's start with the concept of a thing called an inverse, and in particular an inverse of a number. If you've got an inverse of a number, that's the idea that if I flip the numerator and denominator around. So for example, if we've got 3/4, the inverse of this would be 4/3. Now, the idea here is that the inverse is a bit like saying if I did 1 over that number. That's the idea. 1 divided by that number. That will get me the inverse. Now, one of the things that we understand about inverses, if I take a number, multiply it by its inverse, let's go and put finger down, then the multiplication will equal to 1. So for example, if I have these 3/4 and multiply that by 4/3, well, 3 times 4 is 12, 4 times 3 is 12, and 12 divided by 12 would be equal to 1. Well, this is how we can go about our whole dividing matrices things. Instead of dividing my matrix, we can multiply it by its inverse, and this can act like dividing. Now, I would be fairly confident to think, like, what's the point? Why do we divide matrices? And in this exercise, I'm not even going to tell you the real purpose for it yet. However, when we start applying matrices to things such as simultaneous equations and linear algebra, that's when we might have to apply this concept. But let's go and get our practice sorted. Now, the great joy about using the CAS is that the CAS can do all of this complicated stuff for you. However, you will be required to apply your understanding of the different parts of finding an inverse. Well, the first thing we're going to do in this example 12a.1 is show that each of the following pairs of matrices are inverse by multiplying one by the other. So, I'm just going to multiply this. When I have multiplied the two matrices, I get an answer of 1, 0, 0, 1. And that is an identity matrix. An identity matrix where it has everything's zeros except the diagonal that goes from top left to bottom right. If the diagonal from top left to bottom right is simply filled with 1s, everything else with 0, that's an identity matrix. And that is the matrix equivalent of saying the number 1. So in other words, if I have a matrix, let's call it matrix A, capital A, multiply it by its inverse, it will be equal to the identity matrix. Now you'll notice here the inverse symbol is the original matrix, whatever letter we've given it, but it's to the power of -1. That little power to the -1 is the universal symbol for inverses. So for example, if I was to take that matrix here, the 2, 2, 3, and 4, and I was to use the little hat symbol there, the power symbol on my CAS, and type in -1, it will come up with that inverse as before. So thankfully we can do that. So what happened in the days before the CAS? How did we go and find the inverse? How do we do 1 over that matrix? Well, it has a few different steps. Step 1 is to find a thing called the inverse determinant. So the determinant is a weird calculation here. And it would help if I had like a little reference. So here's my reference. So I've got some matrix. Let's call it matrix A, B, C, and D. Well, the determinant is calculated by doing A times D, take away B times C. In other words, the top left corner multiplied by the bottom right corner, take away the top right corner multiplied by the bottom left corner. And so in our example, so we had 2, 2, 3, and 4. That will be 1 over 2 times 4, take away 2 times 3, which will be 1 over 8, take away 6, which will be 1/2. And also the calculator can work this out, because of course the calculator can. There's a little function, it's a bit hard to find sometimes. Personally, I prefer just going into the keyboard and typing in the magical 3 letters that I need. I'm just going to delete that. And the 3 letters that you need are D, E, T. I'll put a bracket there. And I'm going to put in the matrix as required. So here it was 2, 2, 3, and 4. And there we go. So there's the determinant is 2, 1 over 2. So if I was to do 1 over, we can put this into a little fraction. 1 over that determinant, and it's equal to 0.5, which is the same as saying 1/2. So there we go. There's our determinant. So you can either work it out by hand, you may be required at some point to use that formula, or otherwise, of course, you can use the CAS. The next step is to switch the diagonals versus negative diagonals. So step 2, if I've got my matrix A, as I did before that, A, B, C, D, what I need to do is swap the top left and bottom right corners around, and then chuck negative signs on the bottom left-hand corner and on the top right-hand corner. So for example, this would, our original matrix, that 2, 2, 3, 4, would become 4 and 2, then negative 3 and negative 2. That's what I would need to write there. The last step is then to multiply that in the determinant, the 1 over det A, or inverse determinant, by that matrix we switched around. So my inverse determinant was 1/2 times by 4, negative 2, negative 3, and 2, which, if you remember from the last chapter, that would be the same as going 1/2 times 4, 1/2 times negative 2, 1/2 times negative 3, and 1/2 times 2. And ta-da, you will have that inverse that we had there before, 2, negative 1, negative 1.5, and 1. Now, I will say this, that you are not required to be able to work out the inverse determinant for any square matrix that is greater than 2 by 2 for the purpose of Year 12 further maths. And also you should know that you cannot do an inverse of any matrix that's not a square matrix. Also, if your determinant, so if this little fella, that thing at the bottom, is equal to 0, then there's no inverse.